Welcome to the Q&A session 11 from the playlist of Motion in a Plane. The topic is hitting the target from the plane. This topic pertains to the dropping of a bomb from a fighter plane in order to hit a particular target. So the question here is, a fighter plane flies horizontally at an altitude of 1.5 km with a speed of 720 km per hour. At what angle of sight with respect to the horizontal? When the target is seen, should the pilot drop the bomb to hit the target? So I have drawn here one simple figure. So here this is the point B is the target, and this is the point A where the pilot drops the bomb. So when the pilot drops the bomb will have a horizontal speed of 720 km per hour, and its vertical component will be equal to 0. So its horizontal component of velocity this will be equal to 720 km per hour, and its vertical component will be equal to 0. So at this point A, the speed of the bomb in the horizontal direction will be equal to 720 km per hour, and the speed of the bomb in the vertical direction, say this is uy, say this is uy, so this will be equal to 0. And let us say this is the horizontal component, I am just denoting it as ux. So ux will be equal to 720 km per hour. Now in this question, the first thing which we have to do is to find the time, or you can say the time taken by this bomb to hit this target. So in order to find the time, we will first of all calculate the time taken by this bomb in order to reach the ground, and this can be easily found by considering this vertical distance covered by the bomb in order to hit this target at B. Now the vertical distance here is given as 1.5 km. That is, it is flying at an altitude of 1.5 km. So if this is the ground, let us say this is the point O here, and so OA will be equal to 1.5 km. OA is equal to 1.5 km. This is the altitude, or in meters this will be equal to 1500 meters. So when the bomb this bomb is dropped, the vertical component is 0. So let us say this this altitude, say h, is equal to, will be equal to ut plus half gt square. Now in the vertical direction, the velocity has been taken as uy. So uy is equal to 0. So simply h will be equal to half gt square. Now h is known to us, which is equal to 1500 meters. So 1500 will be equal to 1 by 2 into g is equal to 9.8 into t square. So from here, the value of t can be calculated. So t will be equal to 1500 divided by 4.9 under root. So if I calculate this value, this is equal to 17.49. 17.49 seconds. So this bomb will hit the target after at t is equal to 17.49 seconds. Now when this bomb is dropped from this point A, to hit this target, this bomb will follow a projectile motion. And in this projectile motion, the vertical component at the time of dropping is 0, and the horizontal component, it will remain the same throughout the throughout its this flight. That is, the bomb will follow a projectile motion till it hits the target. And during this motion, the horizontal component will always remain the same. So the horizontal distance traveled by the, that is horizontal distance traveled by this bomb will be equal to 720 km per hour. So I have to convert this into meter per second. So in order to convert this into meter per second, I will be multiplying it by 5 by 18, which is equal to 200 meters per second. So horizontal distance will be equal to 200 meters per second. This is the this horizontal speed in meter per second multiplied by the time taken, which is equal to 17.49, and this is in meters. So this is equal to 17.49 into 200. This is equal to 3498 meters. So or from in this figure we can say that OB will be equal to 3498 meters. So the target should be at a distance of 3498 meters from the point O. That is, or you can say from the point O, which is the point vertically below the point at which we have dropped the bomb. So if we drop this bomb, if I am dropping the bomb from the point A, then this bomb will hit the target at a distance of 3498 meters on the ground. So now here we have to find the angle of sight with respect to the horizontal. That is, we have calculated this distance, that is OB is known to us now. Now we have to find the angle of sight with respect to the horizontal, means that this is so we have to basically find this angle theta. So the angle of sight with respect to the horizontal, this angle will be calculated by, let us say this is the point D. Now here AD and OB are equal, which is equal to 3498 meters, and DB is equal to 1500 meters. So this theta can be found by using, we know the this DB and we also know AD. So tan theta will be equal to perpendicular upon base, which is equal to 1500 divided by 3498 meters. So from here, tan theta will be equal to 1500 divided by 3498, which is equal to 0.4288. 0.4288, or we can simply say that theta will be equal to tan inverse 0.4288, and this value will be equal to 0.4288 this is equal to uh, 0.42. This is approximately equal to here theta is approximately equal to, this is approximately equal to 23 degrees centigrade, 23 degrees. That is the angle of sight with respect to the horizontal will be equal to, this is the approximate value, that is 23 degrees centigrade is the approximate value. So thank you very much for joining this session. In this session, the most important thing was the calculation of time taken by this bomb to hit the target, and that was calculated by considering its vertical motion. In the vertical motion, the initial velocity was 0. So by using the equation of motion, that is h is equal to ut plus half gt square, I was able to calculate the time taken by this bomb to hit the target. And since in the projectile motion, the horizontal component always remains the same, therefore we were able to find the horizontal distance, which was equal to the velocity, this speed, which is equal to 200 meter per second. I have converted this 720 kilometer per hour into in meter per second. So 200 into 17.49. So that OB was equal to, that is the horizontal distance covered by this bomb, is equal to 3498 meters. And finally, we were able to find the angle of sight with respect to horizontal, which is approximately equal to 23 degrees centigrade. So thank you very much for joining this session. So in the next session, I will be coming up with the topic of relative velocity. So till then, have a nice day. Bye.